Bum 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 bum. Bum 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 bum. Oh, have I? Why is the chat option unavailable? Did I disable that? Where can I set up if the chat is enabled or disabled? I think it should be here. Yeah, I've enabled it actually. So I don't know. Oh, I guess I was just like it was just YouTube delaying because it failed to catch up with it. That's my guess. Yeah, so here we are again. Let's take some time to take a look at. Wait a minute. Let me make really sure that I have enabled chat. Let me watch this on YouTube. Is there's a link? I don't know. Let's see. Is chat enabled at all? Oh, it's not enabled. Sorry. So I've enabled it. And yeah, that's okay. Let's move on. And today I am actually planning to talk a little bit about extension functions that we have. I have a look at last time but didn't have enough time for it. Let's, because I'm totally new to extension functions, so I'm new to this too. So let's explore it together. Kotlin similar to C# and Gosu. What's Gosu? But I do see a lot of similarities between C# and Kotlin, although I don't know what extension means in C#. Provides ability to extend a class with new functionality without having to inherit from the class or use any type of design pattern such as decorator. This is done via special declarations called extension. Okay, so Kotlin supports the extension function and extension properties. That's something new to me. Extension functions. To declare an extension function, we need to prefix its name with a receiver type. What do you mean? Oh, yeah, that is it. So, i.e. the type being extended, the following adds a swap function to mutable list of integer. So we write a function which its name is swap, and if we want to add it to a collection of mutable list of integer, we add a prefix with the same receiver type name with it. Then we have the two functions, two items here, index1 and index2, and we swap point it with temp and later swap the pointer. So yeah, this is a proof that, well, let me see. So, well, this is a proof that Kotlin is passing in the reference, is it? Temp is the value, so it is. Yeah, so we can update it with, oh, I don't know, maybe this is actually a set under the hood, so maybe it's not something particular with well, yeah, because we haven't changed this integer here, so we don't know if it is something like pass by reference or pass by value. Although in the last episode we talked about it, and we know that every this index and index2 here are both immutable, which means they are kind of treated like value, this val here. So let's move on. So yeah, this is a function which is which has a name swap, and it is an extension function of mutable list of integer. So I don't think this is quite the one we see in math, Kotlin.math. I don't think that's what we have seen earlier. Does not look like so. Yeah, we don't see the package. That's a package, but let's take a look at any one of the function. Let's say max, and its function max, and takes double A and B double. So no, it's not an extension function at all. I don't know, but where were we? Were we at where were we? Let's take a look at where we left last time. Intro, and that's the is lucky if I'm to double. Is it to double? I don't know. To double. So I don't know. I don't think so. It's pow. I think it's pow. Power. So let's take a look at pow. And there it is. This is a function added to the type double, and the function name is power. So that is why we're calling. I don't know. Why are we calling math.pow here? Is this something that is totally different? Well, I don't know. That's interesting. I don't know. Why can we call math.pow rather than double.pow? Let's take a further look into the document and see if it answers this. So yeah, we can make it generic too. So to make it generic, that this is the syntax, multiple list of whatever, and it is of return. Is this a return type? No, the return type is added here in Kotlin function. So this is just a placeholder for generic. Yeah, we haven't talked about generic functions in Kotlin yet, but I'm assuming that everyone knows the Java generics here, so I'm not going to go deep here today. Maybe next time. Let's talk about generic functions next time. So extensions are resolved statically. Yeah, that's. But one thing that I found interesting is also I don't think there is a JVM. There is a Java static keyword in Kotlin that acts as the Java static, but let's take a look at this. Extension do not actually modify class they extended. By defining an extension, you do not insert new member into a class, but merely make new functions callable with the dot notation. Dot notation, that's a point, on variables of this type. So yeah, we're writing an extension of class C which calls foo, and it returns just C, simply returns C. So we can call this print foo. This is a little bit complicated here. So there's a print foo function, normal function of class C, and it calls the c.foo, and if we pass a d into it, wow, that's complicated. What's open? Kotlin open class in what is let's take a look at it. in Kotlin, open is same as not final. So yeah, so by default everything should be final then, I guess. Yeah, let's assume that and revisit if we run into it later. So this class C is inheritable. I don't know. Is there that even that word? Well, we can inherit this class C here when we declare it as an open class. So if we print foo D, then in this D in this C, wait, what is this? Oh, if we add somewhere call as print foo D, then it pass it in and it calls c.foo, but because it is these extension functions are resolved statically, so it would actually print statically, so it should be C here, I guess. This example will print C, yeah, I'm right. Because it's the extension function being called depends only on the declared type of the, yeah, declared type. So it is calling c.foo, which is C. So yeah, this is the point. That's what we want to talk about. If a class has a member function and an extension function is defined which has the same receiver type, I have no idea what it is talking about. The same name is applicable to given arguments. The member always wins. For example, here's again that function. Okay. When we call the member function always win over extension functions. Like say there is a member function that is called foo and it prints member, and there is also an extension function is also having the name foo and it prints extension. So when we call c.foo, although it is resolved statically, but member always wins, so we print member here. However, it's perfectly okay for extension function to overload members which have the same name but a different signature, which means have the same different parameters passed in. So c.foo1 will print extension. That is, of course, nullable. Why nullable? Any dot. So this is, I don't know, this is nullable, I guess. This is why it is talking as well. Note that extension can be defined with a nullable receiver type. Such extension can be called on an object even if its value is null, and can check for this equals null in body. Okay, so this is again reminding everyone of the null check, the autocast. Yeah, autocast. Because we check this is not null, so after that we have we know it is not going to be null, so we can call a toString here, the normal toString here. This is what allows you to call toString in Kotlin without checking for null. Yeah, this is, yeah, because toString is itself is I'm actually wondering this. What is an Annie? Annie in Kotlin? No, not Annie. It's Annie. Kotlin. Let us open the root of the Kotlin. That's the object in Kotlin. Yeah, so because Annie has an equal hash code toString just like Java object, so we can do the toString here. If we write an extension function of type any question mark nullable any, and every time before that, when we call toString, it would give us it would warn us or just report an error if we try to call null dot toString, if that value is nullable. But with this, that would no longer be the case because but member always win. I'm wondering what's happening here, because member always win, and it always have a member function which is toString. But okay, I guess it is overloaded in some way that it differentiates between nullable any and non-nullable any. So that's the extension function. I'm still wondering why we can do this here, but seems like we can simply do the double.pal version here, I guess. Let's run a test, because there's a no. So oh, so that's actually something that's become interesting. How about this 10.2double.pal position unresolved reference power, but it actually writes function double.pal x double here. Oh, this is not the one I want, right? Oh, okay. To the power of x. Is it like not available in older versions? Which version are we on here? I need to take a look at it. So no, not jobs. My account? I don't think so. Where's the forum? And languages, tournaments, feature request. No, box, no. So this is weird. Profile, my account, maybe language, program languages. So I think this only changes the profile one, I guess. Kotlin. Yay! I'm not Kotlin writers, but wondering. Tools. No. This is not what I'm searching for. Ah, that's my contact. No, please don't leak my info. Maybe I should add that part. I don't know. I don't think anyone is going to be interested in me anyway. But that's where can I choose my language? Language, please. My account. Friends, no. Wow, this is irritating. Here, maybe. Ah, here it is. Wait a moment. Kotlin, there it is. Kotlin. I really need some code signal. Compiler version. Yeah, there it is. Kotlin, where's my Kotlin? Haha, there it is. It's 1.13. So that's why we only have some. Okay. So that's why we only have this java.map. Oh, and the java.map is imported. Oh, that's that's irritating. So actually we're calling the Java map then, I guess. So where's my problems? Tournaments, arcade. So because the Java version is passed in, so this math is actually Java math, and so that's why it's taking these two. Makes sense, but that's irritating. Anyway, so I should only look at 1.1 then. So Kotlin.math doesn't have that power yet. But well, this actually makes me wonder if I really need to try it here, because that's 1.2, 1.1 is a little bit outdated. I should have requested the CodeSignal team to update to 1.2 at least, and because 1.3 is already, you know, out, official. Yeah, so let's move on to the Untitled Receiver. Oh no, the extension properties. So if we similarly to functions, Kotlin supports extension properties. So this is not a function because we don't have that brackets, and it is the it's less index. But I'm wondering, where do we define these extensions? If how does Kotlin know if we define these extension in some random files? Know that since extensions do not actually insert members into classes, there's no efficient way for an extension property to have a backing field. Makes sense. This, if you have forgotten what backing field is, we've talked about it in episode like the last or the one before that one. The backing field is for getters and setters, and if we want to manipulate the behavior of the getter and setter with the values it's receiving or it's setting, then you need this backing field. So this is why initializers are not allowed for extension properties. Their behavior can only be defined by explicitly providing getters, setters. Initializers, it cannot. I don't quite get it. Are not allowed for extension. Oh, so we can't initialize it with some like initializers. We can only provide getter and allowed for extension. Okay, so last index is the size before it. Okay, that's handy. So initializers are not allowed here, so it is yeah. So this is inherited, writing something like get equals to, I don't know, what is this? Initializers. Value initializers. It's setting, or I don't know. Getter and setter. That's so companion object extension. If a class has a companion object defined, you can also define extension functions and properties for the companion object. So this looks something like interface or callbacks. If it there's a my class and it has a companion object. Will be called companion. Okay. So it has a if this is something that you leave a space for altering for the other class users. So my class, the companion, that although I'm not quite sure why these are available at this moment. I don't know what the use case might be, but I can tell that it's something that we only declare when we want the users to have some scope or to author, or I don't know. So scope of extension. Oh, this is very long. We can actually just we might do over time, but yeah, let's look at it as far as we can. Scope of extension functions. Most of the time we define extension on the top level directly under packages. Okay, so we use this package, and in the class that we're going to use it, we declare this is answering the question that I just asked. Which file do we write extension functions in? So import it after the package, after the import. Yeah, we first import it, and then wait, what is this usage? Buzz.u import. Oh, okay. So it's actually defined in a standalone file, and we declare extensions that are foo.bar, and there's an extension function for type bass, which has the name goo. And later, when we include both foobar and foobar.goo, which is the function that we want to use here, or maybe oh yeah, that's another way to do it. If we import everything from foo.bar, this one would be included too, because it's in the package foo.bar, and then we can use it. So yeah, it is valid only when we have explicitly imported it. Declaring extensions as members. Inside a class, you can declare extension for another class. Inside such an extension, there are multiple implicit receivers, object members of blah blah blah, assets without qualifier. The instance of the class in which the extension is declared is called the dispatch receiver. This seems to be really advanced. I don't know if I can understand it. Inside a class, you can declare extensions for another class. Of course, because we have this class D here, and we can. Which one is it? Bar bez. What? Why? This is not. Okay. We extended with function d.foo, and in this foo function it calls bar, and it calls baz, because this extension is both of scope of both D and C. Then we can function color d, put it in, and d.foo. Okay. So that's what it means here. There are multiple implicit receivers. I don't know what receiver means here, but that's it. Implicit receivers are objects members of which can be accessed without a qualifier. So without a qualifier, it actually means we don't add C or D or any qualifier that hints which instance is going to call this bar and best. The instance of a class in which the extension is declared is called dispatch receiver. So wow, this is really advanced. Let's see. So this d.foo here means the instance of the class in which, extension is declared, which means this C instance of class C is a dispatch receiver, which is one of the implicit receivers, and an instance of the receiver type of the extension method. Receiver type, which is I think this one, receiver type, is called extension receiver. So yeah, this call is implicitly calling the dispatch receiver, and this one is implicitly calling the extension receiver. Well, that's hard. In case of a name conflict, of course, I hate name conflicts between the members of the dispatch receiver and the receiver. The extension receiver takes precedence. To refer to the member of the dispatch receiver, you can use this. So if you use this at C, then you can call C to string. Else the dispatch, the extension receiver takes precedence, so it's basically the D1 in this case. The extension declared as members can be declared as open and overridden in subclasses. Extension as member. So, oh, this holy world, this is difficult. This means that the dispatch of such functions is virtual with regard to the dispatch receiver type, but static with regard to the extension receiver type. Ha! Wow, that's hard. Let's try to get it. Because in class D, we're trying to... Oh no, actually there's the open class D and the open class C. And because we declared this extension as open, so it is thus what is it trying to say here? It is virtual with regard to the dispatch receiver type. Okay. So this is hard. So let's just directly look at the example. So if we initialize a C instance of C, then we call caller and pass a D into it. We then call a D.foo, and this D.foo is only exist in this open extension function. So it should call D.foo in C because we're passing D rather than D1 in. So yeah, it indeed called D.foo in C. What about if we have C1, which is a class that inherits class C? Then we call its caller dot D, because caller is not overridden here, so it calls D.foo, and because D1, because it is of type C1, C1. So the D.foo defined in C1 is here. It calls D.foo in C1. I don't get what does it mean when it says dispatch receiver is resolved virtually. let's look at it again. C1 dot color okay. So because both color because both d.foo are implemented, are overridden or extended in class C and D, it is resolved virtually. By virtually, it means it is going to have act differently based on its inheritance tree. So it is going to be affected by this C or C1 class instance. However, because extension receiver is resolved statically, it's going to use this one whenever it can, just based on what extension function it is calling. So even though we are calling this c.color d1 here, because color is declaring this d as a type of as an instance of type of class D, so it's going to call a D class D's d.foo whenever it can. So even though we're passing d1 here into it, we still see d.foo in C here. Okay, that's the last part. Note on visibility. Extension utilize the same visibility of other entities. Okay, we really should have visited this one earlier than we start this one. So this one is planned in our next lesson. As regular function declared in the same scope would, for example, an extension declared on top level of a file has access to the other private top level. Well, we're going to go through this next time and come back here. So motivation. So why are we defining these extensions? In Java, we are used to classes named utils, like file utils, string utils, and so on. The famous Java collection to the same breed. And the unpleasant part about these utilities is that the code that use them look like this: swap, max. Those class names are always getting in the way. We can use static imports and get this swap. This is a little bit better, but we have no or little help from the powerful code completion of the IDE. It would be so much better if we would say list.swap and list.blah blah. But we don't want to implement all the possible methods inside the class list, right? So this is where extension help us. So that's the purpose of the extension functions. And I hope you enjoyed this episode because we're not writing any actual code today. But I promise you that in the next episode, we're going to write some code, which is the next problem, which is sort by height. We're not going to look at it today, but it seems like to be a pretty straightforward one. So, see you next time. See you tomorrow. So, why are we defining